Hello, I'm Brian Catt. Um, I'm not going to talk about me very much. You can find out about me elsewhere. I'm a physicist and engineer, and I want to try to say something to you about the facts and the science of climate change, which are easily understood by any normal person who's gone through the education system at the most basic level. And that is, you have been lied to. You've been lied to by your government, you've been lied to by the United Nations, and you've been lied to by the academics paid to support the lies. It works like this. You are told that we must decarbonize our precious, cheap, plentiful supply of energy that maintains our developed economy in the name of climate change, and that climate change is dominated by carbon dioxide emissions in the atmosphere, a tiny 0.04% of the total atmosphere, less than all the argon in the atmosphere, which has changed, and it's risen by 50% due to human caused emissions. Okay. What it has not done is dominate climate change. And this is very simple to check on the most basic of facts since records began. And perhaps I'll finish this little section by saying records did not begin in 1850. That is a deceit, a deliberate deceit. You are led to believe that we don't know what happened before 1850. Of course, we know what happened before 1850. How else do we know how the ice ages came and went and changed and what the temperature of the Earth was back 500 million years? And the answer is there are proxy measurements. We can Traces are left in nature of the isotopic elements oxygen, carbon, and others, which tell us what the temperatures, carbon dioxide concentrations, and were in the past. Those are the two things we're interested here. Okay, and they come from sediments, ice cores, and other such measurements, stalactites and stalagmites all around the world. And I'm now going to show you how they so simply show you that you've been lied to. Okay, let's get some numbers up. Okay, here are our numbers. So this is the records from one of the ice cores in Antarctica. There are two well-known ones. Vostok was the one at the Russian station from 2000. You can see the reference down the bottom there. It's by Petit et al. It's easy to find. So you can go away and get the data down, download it, plot it for yourself. What we have here is the proxy temperature measurements and the carbon dioxide measurements. You'll see the axes are on either end of the chart here, and the base year for this is 1995, which is the 0th year for temperature, which is a little bit warmer, about half a degree. We currently are above the average in 1995. So let's look at this. Remember what we're looking at. Carbon dioxide is the dominant control of temperature. Okay. So what's the temperature now? What's the carbon dioxide now? Well, it's about compared to the anomaly, the difference, we're about half a degree warmer at 420 parts per million of CO2. Now, what we would expect is that if there is yet more CO2, it will be warmer, and if there's less CO2, it will be colder. That's what the dominant control means, okay? So let's go back to the last interglacial. These periods happen every 100,000 years or so. It depends on how the Earth is actually moving around the sun. It varies. There are several cycles that combine. You don't need to go into that. You can read that up as well. Let's go back to the Eemian, which was much warmer than our current one. There were hippos were swimming in the Thames. There were elephants on cave lions, also in the Rhine. And there was almost no ice left on Greenland in a similar geological position to today. And the temperatures were roughly 4 degrees higher than they are now at the poles. A bit less here. It gets less as you go towards the equator. So hang on a minute. Did I just say the temperatures were higher? When actually, if you look, you'll see that the levels of carbon dioxide involved are about 280-ish, maybe 290. So there's 290 parts per million, and it's 4 degrees warmer. Now is colder with 50% more CO2. So on the very first check we've done, this statement about the dominant control of climate is CO2 is just nonsense. If we go back to the previous two interglacials to the Eemian, you'll see that again we're looking at over 2 degrees warmer at 280 parts per million of CO2, and definitely 4 degrees warmer back in the, what is that, 325,000 years ago, interglacial. Again, with what, 300 possibly ppm, and I've marked that up on the diagram. You can look at it, download it, check it for yourself. So in all these cases, we are now at a temperature which is between 2 and 4 degrees warmer than now, when now has CO2 levels that are 50% higher. So nothing about the long-term record of the ice age cycles during the interglacial periods that we currently are in, the Holocene interglacial, support the claim that CO2 is the dominant control of climate. In fact, it looks like it's the reverse. It isn't. There is a small effect from CO2, warming effect, but it's nothing like dominant. So that claim is just bogus. You've been lied to, obviously. Well, okay, I hear you ask. That's a fairly stunningly convincing set of evidence of how these dependencies have changed, as we are told they have been. Well, first of all, I'd just like you to watch a little video here. And this is not from, so you don't have to listen to me all the time. And here is a very well-respected academic explaining what they have found in one, there are many, of the Greenland ice cores, the Nordgrip, that was buried, and how the temperatures have varied in the past, back to 10,000 years ago. Here we go. Enjoy.
This ice is from the Viking Age, around the year 1000, also called the medieval warm period. We believe that in Greenland, the medieval warm period was about 1.5 degrees warmer on average than today.
Nordgrip, the Greenland ice core project, is being reopened to drill the last few meters through the ice sheet to the rock beneath the research station. The ice core, over 3 kilometers in length, has been hauled up to the surface piece by piece and contains important data on the history of the climate of the Earth.
Here we have our picture of the temperature reconstructions that we have from Greenland in a graphical form. And if we go back along this axis, it's going back in time. This is the last 8,000 years we have plotted here. On this axis we have the temperatures at the site in Greenland, and we can see that if we go back from now about 4,000 years ago, we would have temperatures up here for about 4,000 years that were 2.5 degrees warmer on average than today. Now, as we approach our time, we can see that in the period between 4,000 years ago and back to the period 2,000 years ago, which is actually the Roman age, the temperatures have been decreasing in Greenland by 2.5 degrees. Then the temperatures increased gradually up to a maximum point around the medieval warm period, we call it 1,000 years ago. And then temperatures declined and goes down to a minimum around 1650 AD, comes back up a little in the 18th century, and then around 1875 we have the lowest point in the last 8,000 years, right here, and that matches exactly the time when meteorological observations started.
Other core samples from elsewhere in Greenland confirm that the Little Ice Age ended about 140 years ago, at the coldest point in the last 10,000 years. the natural, pronounced alteration of warm and cold periods back in time has also been confirmed elsewhere in the Northern Hemisphere. Carbon-14 dating of organic matter from peat bogs and tree rings confirms the pattern. So do data from stalactite caves in China and measurements from North Africa.
The problem is that and I agree completely that we have had a global temperature increase in the 20th century. Yes, but an increase from what? Probably an increase from the lowest point we've had for the last 10,000 years. And this means that it will be very hard indeed to prove whether the increase of temperature in the 20th century was man-made or it's a natural variation. That will be very hard because we made ourselves an extremely poor experiment. We started to observe meteorology at the coldest spot in the last 10,000 years.
Okay, so this is the last bit, the wrap really. The carbon dioxide levels during the last 10,000 years coming up to the present time. We've just seen how it was noticeably warmer in around 4,000 years ago, and that's the Holocene optimum period that Prof. Stephenson was talking about. And since then it's fell to the lowest in 10,000 years before rising 1.5 degrees to where we are now. Still 2 degrees colder than the Holocene warm period. What was the CO2 level doing then? Let's see. The slide here is from Antarctica, and it's from the Vostok ice core, which you've already seen right back at the beginning, and that's the orange line. And the red line is Epicodome C, the European ice core, and both of them are showing you carbon dioxide for the last 14,000 years, as recorded by the ice cores. Pretty simple to see that during the periods that Prof. Stephenson just covered, from 10,000 years ago to 4,000 years ago, when it was warmer than now, CO2 levels were 270 parts per million. They're now 420 parts per million, and it's still nowhere near as warm as it was back in the Holocene optimum period that we've already covered. So I think I rest my case there. Less CO2, hotter temperatures during this current single warm period, as well as in all the others that we looked at earlier. Okay, that's it. I rest my case. Thanks for your attention. Okay, so I hope you are fairly convinced that if there's one thing that CO2 is not, it is the dominant control of climate change. All of the evidence we have here suggests the opposite. And again, there is a small actual warming effect, but it's not controlling, it's not even significant, and it's very well controlled by the natural feedbacks that Earth has to stabilize itself in space. And that's a whole other story. What I'd like to do is to make a very clear point about the difference between scientific models, the probabilistic computer models, where they're run on the guesses of their programmers, and deterministic science, which is simply a very clear theory which can be tested by the observations. And if the observations disagree with the theory, it isn't the observations that are wrong. But I'll let Richard Feynman make that wrap for me. So thank you for watching, and I'm always happy to answer sensible questions.
If it disagrees with experiment, it's wrong. And that simple statement is the key to science. It doesn't make a difference how beautiful your guess is, it doesn't make a difference how smart you are who made the guess, or what his name is. If it disagrees with experiment, it's wrong. That's all there is to it.
To be really clear, as regards the evidence I've presented, and indeed things I say to do with the laws of physics. I strongly recommend anybody who's watched this and who feels that it has any kind of merit but are unsure about what I have said, simply look at the references to the data, or indeed ask for more, so much more, and that support this particular position. I've just kept it simple to the very well-known science that we've had since the year 2000 at least. So it's all been well known for a long time, and I invite you to make independent tests of your own by simply going on the web, looking for the evidence and finding it. It's not what people say about the measurements or debunked measurements and all the rest of this nonsense. They have to have data, unless you're a politician, and then you just make it up and lie about it, which is exactly what they have done. There. I like to be clear on this point.